So 8th point of circles. Finding equation of circle if 3 points are given. So if 3 points on the circle equation are given, we need to find equation of circle. There are different methods to find the equation of circle using 3 points on the circle, and I will discuss all those different methods. Mostly I will discuss now 3 different methods. After that I will give you one example also. Basically here we have a circle, and on this circle A is one point, somewhere B is another point, and C is another point. Okay, using these 3 points A, B, C, we need to find equation of circle. How to find equation of circle using these 3 points? Method 1. So first method of finding equation of circle using 3 points on the circle is identifying its center. Suppose center of this circle, say it as S. We know that center of the circle is equidistant from all the vertices. Distance from S to A is equals to distance from S to B is equal to distance from S to C, right? All these distances are equal, and we call those distances as radius also. Since given 3 points in the sense the coordinates of those 3 points A x1 y1, B x2 y2, C x3 y3 are given points on the circle. Our task is to find equation of circle. In method 1, you just let center of the circle S as alpha beta. By taking S as alpha beta, using this particular logic, center is equidistant from all the vertices. We have SA is equals to SB is equals to SC. S is alpha beta. We have ABC as x1 y1, x2 y2, x3 y3. Now just square everything. Use distance formula. Use distance formula between S and A. Okay, and then square it. So we have SA square is equals to SB square is equals to SC square. So by using SA square is equals to SB square, we have one relation between alpha beta. By taking SB square is equals to SC square, we have another relation between alpha beta. Here we have equation 1, here we have equation 2 in terms of alpha beta. Then you just solve this equation 1 and equation 2, we will get alpha beta. After having alpha beta, which is center S. Okay, so from there we have S as alpha beta. So since S is the center of the circle, now from that center S, find distance to any one of these 3 points. We have 3 points on the circle. Just use any one point among these 3. Say for example A, find distance between S and A, and that is the radius. So it is easy to find the center, it is easy to find the radius. So use these two, center and radius, to find the equation of the circle using center radius form. Is it clear? This is method 1. This is the best and the first way of finding circle equation if 3 points A x1 y1, B x2 y2 and C x3 y3 are given. Okay, once again just revise. I have 3 points. I don't know center. Let the center as S alpha beta. We know that center is equidistant from all the 3 vertices. So write SA, SB, SC are equal. Square them. Equalize these two and equalize these two. We will get 2 equations in terms of alpha beta. Solve those 2 equations to get alpha beta, which is center. So initially we don't know center. Let it as alpha beta. Finally we are finding those 2. So we have center. After having center, find distance between center and any one of the point, that is the radius. Center and radius, use center radius form. Okay? Think about it. This is the first method, and then I will explain second method. If 3 points are given to find the circle equation, method 2 is using general form. We will have general form of the equation, circle equation, as x square plus y square plus 2gx plus 2fy plus c is equals to 0. This is the general form of the circle equation. For an instance, this is in terms of x and y. So write it like f of x comma y. F of x comma y is x square plus y square plus 2gx plus 2fy plus c is equals to 0. Since these 3 points ABC are on the circle, these 3 points ABC satisfies this general form equation. This is the general form, right? These 3 points will satisfy this equation. So substitute x1 y1 in this equation, you will get one relation. Substitute x2 y2 in this relation, you will get another relation. Substitute x3 y3, there is a third relation. Solve those three relations to get the G, F and C. After having G, F and C, that's enough to write circle equation. This is circle equation, general form. We don't know G, F and C. To find this G, F and C, use three points. Initially f of a, that means replace x with the x coordinate, y with the y coordinate. So x1 square plus 2g x1 plus 2f y1 plus c is equals to 0. Just think about it, everybody. Just you write first point in the circle equation. Similarly, you just write second point. I say it as f of b, and then substitute x coordinate and y coordinate of third point in this equation. You will get another relation. Okay, solve these three relations. If you solve these three relations, you will get z value, you will get f value, you will get c value. After finding g, f and c, just plug in this general form. It represents circle equation. Okay, there is method 2. Have a look. Now coming to method 3. Okay, another process to find the circle equation using three given points. Okay, so we have a circle, right? So given 3 points, one point is A, another point is B, and somewhere the third point is C. To find the circle equation, we need center and radius. If we know center, then it is enough. To find the center, what we need to do? Just think about it. Here we have A and B on the circle. Okay, just join AB. If we join AB, this AB is a chord of the circle, right? And now for this AB, you just draw perpendicular bisector. Okay, this is perpendicular bisector. I think you all know about the perpendicular bisector. Perpendicular bisector passes through the midpoint of AB as well perpendicular to the AB. Okay, I think you all completed straight lines. In straight lines, if you have a point A x1 y1 and B x2 y2, you know the way of finding equation of perpendicular bisector. To find any line equation, we need point and the slope. For this perpendicular bisector of AB, midpoint of AB is the point, and you simply, since this line is perpendicular to AB, we will find slope also. So this line L1 is perpendicular bisector of AB. So we need to find equation of this perpendicular bisector. And from the properties of circles, which you learnt in your earlier classes, that like, okay, center of the circle always passes through the perpendicular bisector. So this is the perpendicular bisector for the chord AB. Surely center lies somewhere on this perpendicular bisector. Okay, now you just join BC also. After joining BC, you just find perpendicular bisector for BC also. This line is perpendicular bisector of BC. Okay, you take this line as L2, and this L2 is perpendicular bisector of BC. Okay, as we discussed, center of the circle lies on perpendicular bisector. This is one perpendicular bisector, center lies on this line. This is another perpendicular bisector, center lies on this line. So for sure, this point of intersection is the center of the circle. Okay, so we need to find equation of L1 as well equation of L2 using the concept of straight lines. After having L1 and L2, L1 is one line, L2 is one line. The point of intersection of L1 comma L2 is alpha comma beta, which is the center of the circle. So After having center, just find distance SA, mark it as radius. So we have center, radius, use center radius form to find the circle equation. This is method 3. Okay. Now I will give you examples related to this that will clear all your doubts. Okay. Copy this. So finding equation of circle if 3 points are given. We just discussed about different methods. Now I have 3 points 2, 3, 0, 2, 4, 5 on a circle. Our task is to find equation of circle. Okay. So now I am using method 1. In this method 1, we need to let center of the circle. Let center S is equals to alpha beta. So if center is alpha beta and mark these 3 points as A, B and C. A, B, C are 3 points on the circle. S is its center. It is very clear that S is equidistant from all these 3 points. So what we have? We have SA is equals to SB is equals to SC. Distance between center to the A is equal to distance between center to B is equal to distance between center to C. Now I need to use distance between these 2 points, distance formula. Okay. So before using distance formula, you just square this equality. So we have SA square is equals to SB square is equals to SC square. Now SA square, distance between 2 points, distance formula. So root of x2 minus x1 whole square plus y2 minus y1 whole square. Here we have square. The root and the square will get cancelled. So we have this SA square as alpha minus 2 whole square plus beta minus 3 whole square. And this is equals to SB square. Distance between S and B. So what we have? Alpha minus 0 whole square plus beta minus 2 whole square. That is equals to SC. Distance between these two. And we have this as alpha minus 4 whole square plus beta minus 5 whole square. Just have a look. This is distance between S and A. This is distance between S and B. And this is distance between S and C. Our task is to find center first using this relation. Okay. Now we need to simplify clearly. Alpha minus 2 whole square plus beta minus 3 whole square. How to write this? Just have a look. So this can be written as alpha square plus beta square minus 4 alpha minus 6 beta plus 13, 9 plus 4. And now alpha minus 0 whole square plus beta minus 2 whole square. Alpha square plus beta square minus 4 beta plus 4. And now this one. This is equals to alpha square plus beta square minus 8 alpha minus 10 beta plus 25 plus 16 is what? 41. Okay. Now after this, just imagine these two are equal, right? So all these are equal. So simply cancel this alpha square, beta square everywhere. After cancelling this, from the first two relation, what we have? Minus 4 alpha minus 6 beta plus 13 is equals to minus 4 beta plus 4. Is it clear? So collect everything this side, or you may send that side. What you have? 4 alpha sending that side, 6 beta minus 4 beta plus 2 beta minus 4 minus 13 minus 9 is equals to 0. Is it clear? 4 alpha plus 2 beta minus 9 is equals to 0. Okay. And again, then from these two relations, when you equalize, collect everything this side. 8 alpha, collecting 10 beta this side, 10 beta minus 4 beta is 6 beta, and 41 this side. 4 minus 41 is 37 is equals to 0. So we have finally two relations between alpha and beta. We need to solve these two to get alpha and beta. Just think about it, how to answer this, how to find alpha beta. Okay. So after proceeding in such a way by taking center as alpha beta and SA is equal to SB is equal to SC. On simplification, we have alpha value minus 5 by 2, beta value 19 by 2. Okay, I am going to erase this part of the board. Okay, finally, using this relation SA is equals to SB is equals to SC, we found center of the circle as alpha beta, that is the center. After having center, we need to find radius also. Now radius, okay, just a minute. So therefore center is equals to minus 5 by 2 is x coordinate of the center and 19 by 2 is the y coordinate of the center. After having center, we need to find radius, and that radius is distance between any one of these points to the center. So radius is equals to SA. So what is that SA? That is equals to square root of, again, distance between these 2 points. Okay, you may use anything, SA or SB or SC. I will use SB because it is 0, right? Gives some comfort. Okay, x2 minus x1. x2 minus x1 is simply nothing but 5 by 2 whole square plus y2 minus y1, 2 minus 19 by 2 whole square. We need to simplify, and that is equals to, under the square root, this is 25 by 4 plus 2 2's is 4, 4 minus 19 is minus 15, and its square is 250 by 4, 225 by 4. 225 plus 25 is what? 250, right? Okay, 250 by 4 is nothing but 125 by 2, and the radius is nothing but root 125, which means 5 root 5 by root 2 is the radius. Center is minus 5 by 2 and 19 by 2. Okay, whereas radius is 5 root 5 by root 2. After having center and radius, whose center radius form x minus h whole square plus y minus k whole square is equals to r square to represent the circle equation. Okay, copy this.